For over 400 years, humanity has studied the sky. From Galileo's first wooden telescope, turned toward the craters of the Moon, to the massive space observatories currently orbiting Earth, each generation has built a better eye. We have spent centuries climbing a ladder of light and glass. The Hubble Space Telescope revealed the sheer, breathtaking beauty of the cosmos, the pillars of creation, and the birth of stars. The James Webb Space Telescope peeled back the curtains of dust to reveal our origins, looking back to the very first flicker of light in the universe. But the Habitable Worlds Observatory, the HWO, was built for a fundamentally different question. It wasn't built to see how the universe began, but to see if we are a solitary accident in its vastness. It was built to ask, are we alone? The Maryland morning was crisp and biting as James stepped through the glass doors of the Goddard Space Flight Center. Outside, the sun was just beginning to bleed over the horizon. But inside the facility, the lights hadn't been turned off in over 2 years. James, the lead thermal engineer for the HWO, clutched his coffee mug, staring through the high-strength glass of the observation deck at the gargantuan machine resting in the clean room. It wasn't just a telescope, it was the physical manifestation of humanity's oldest mystery. Its golden hexagonal mirrors shimmered like the pillars of an ancient celestial temple, reflecting the dreams of thousands of American engineers who had spent decades preparing for this single moment. Dr. Sarah Miller, the project's chief scientist, walked up beside him, her eyes heavy with exhaustion but burning with a quiet, fierce intensity. She leaned against the railing and whispered that she remembered when they first sketched this on a napkin, back in 2030. Back then, skeptics said it was impossible to see a tiny, rocky planet hidden in the blinding glare of a sun-like star. But today, they were standing on the precipice of the impossible. James gestured toward the mirror array, explaining that the ultra-stable segmented mirrors were engineered to a level of precision that defied common logic. Each segment had to be aligned to within a fraction of a hair's width. If the mirrors shifted by even the width of a single atom due to the extreme cold of space, the entire mission would be a billion-dollar failure. But the true heart of the HWO was the coronagraph. Dr. Robert Vance, the team's lead optics specialist, often used the same analogy to explain it to Congress. Imaging an Earth-like planet was like trying to spot a tiny firefly hovering an inch away from a massive stadium floodlight located in Los Angeles, while you were standing in New York City. The coronagraph was designed to act as a sophisticated internal mask, perfectly blocking the star's overwhelming light so that only the faint reflected glow of the planet, the pale blue dot, could reach the senses. It was a feat of American engineering that had never been attempted at this scale, a mechanical eclipse held in the palm of a satellite. The goal wasn't just to see a speck of light, but to tear that light apart to find the secrets hidden within. Sarah pulled up a data simulation on a nearby monitor, showing how the telescope would utilize high-definition spectroscopy. When light from a distant star passes through a planet's atmosphere, the molecules in that air act like filters, absorbing specific colors of the light spectrum. Sarah explained that every gas has its own unique fingerprint. Using inline latex inline notation to track the data, the team looked for specific absorption lines. If there is oxygen, O2, the rainbow of light will show dark, missing lines at exactly 760 nanometers. If there is ozone, O3, it leaves a distinct signature in the ultraviolet. But the ultimate prize would be methane, CH4. In the presence of oxygen, methane shouldn't exist for long because they react and cancel each other out. If the HWO found both, it would mean something on that planet was constantly pumping gas into the air. On Earth, that something is life. Across the United States, from the labs in California to the launch pads in Florida, thousands of people had poured their lives into this singular moment. The HWO was designed to be so stable that it could stay focused on a target while floating 1,000,000 miles away in the void of space at the second Lagrange point. Its precision was such that if someone was sitting in Washington, D.C., trying to look at a quarter in New York City, they would be able to read the date minted on the coin without a single blur. Sarah looked at James and noted that people often asked why they spent so much time and money on a machine that looks at empty space. Her answer was always the same, so that when our children look at the stars, they don't see a cold, empty void, but a neighborhood. They see a home. The launch window was opening. The final checks were green, and for the first time in history, humanity was about to open an eye that could truly see into the soul of other worlds. The year was 2047, and the silence inside the Mission Control Center at the Space Telescope Science Institute in Baltimore was heavy, almost suffocating. The Habitable Worlds Observatory had been in orbit for years, but today was the day the data from a G-type star, a sun-like twin 38 light-years away, was finally being downlinked in its entirety. Dr. Sarah Miller sat at the center of a semicircle of monitors, her fingers hovering over a mechanical keyboard. Beside her, James watched the raw telemetry streaming in from the Deep Space Network. For months, the HWO had been staring at a tiny, unremarkable patch of blackness near the constellation of Cygnus. Now, the star's light had been suppressed by the coronagraph, and for the first time, a faint, flickering blue pixel emerged from the noise. "There it is," James whispered, his voice cracking. "Target confirmed. Planet designation, Kepler-452X. The room, usually filled with the hum of servers and quiet chatter, went bone-dry silent. On the main screen, the image wasn't a swirling marble of clouds and continents. Not yet. It was a pale blue dot, a single point of light that represented an entire world. But that single point of light carried a message. Sarah initiated the spectroscopic analysis, the software beginning to dissect the light reflected from 452X's atmosphere. As the photons were sorted by wavelength, a jagged line began to crawl across the screen, forming a graph that would tell them what that world was made of. The first spike appeared in the infrared. "Water vapor," Sarah announced, her voice steady but her hands trembling. "Copious amounts of it. We have an ocean world, or at least a very humid one." Then a sharp dip appeared at the 760 nanometers mark. Oxygen, molecular oxygen, detected at levels comparable to Earth's Proterozoic eon. The team exchanged looks of disbelief. Oxygen was a biosignature, but as any geologist would tell you, it could be produced by the photodissociation of water. It wasn't proof yet. Then came the anomaly. A second, smaller dip appeared further down the spectrum. "Methane," Robert Vance called out from the back of the room. "We have CH4 at nearly 1.8 parts per million." Sarah stood up, staring at the two lines, oxygen and methane, sitting side by side on the graph. In a laboratory, these two gases are like fire and ice. They cannot exist together in an atmosphere for long without reacting to form carbon dioxide and water. To see them both, meant that something on the surface of Kepler-452X was constantly, aggressively replenishing them. On a dead rock, these gases would reach equilibrium and vanish. But here, the atmosphere was in a state of chemical disequilibrium. Individually, these gases can form naturally through volcanic activity or ultraviolet radiation, Sarah told the room, her voice now echoing with an emotional weight that bypassed scientific jargon. But together, they are unstable. On Earth, this specific imbalance exists for only one reason: life. A sudden, chilling silence fell over Mission Control. There were no cheers, no popping of champagne corks, only the sound of 30 people realizing that the history of the human race had just been divided into two eras: before and after. The blue pixel on the screen seemed to pulse, a heartbeat across the vacuum of space. They weren't looking at a rock, they were looking at a world that was breathing. The data rechecked itself. The algorithms confirmed the signatures, and the reality set in. 38 light-years away, a sun just like ours was warming a world that looked chemically exactly like home. "Are we sure?" James asked, his voice barely a whisper. Sarah looked at the 73% probability index flashing in yellow on her terminal. "As sure as we can be without standing on its soil, James. We've found it. We've finally found it." The atmosphere at NASA headquarters in Washington, D.C. was not one of celebration, but of a heavy, calculated tension. While the world outside was beginning to catch wind of a major discovery, the internal mandate was clear. Extraordinary claims require extraordinary evidence. Dr. Sarah Miller stood before a board of directors and representatives from the White House, her face pale under the fluorescent lights. She knew that a single mistake here wouldn't just ruin her career, it would permanently damage the credibility of science itself. NASA did not declare alien life. Instead, they released a statement phrased in the dry, cautious language of academia. Observation of anomalous atmospheric disequilibrium on Kepler-452X. "We are not calling them aliens," Sarah told a room of frantic PR leads and junior scientists. "We are calling it a high-confidence biosignature. There is a difference." The verification process was grueling. For 6 weeks, the HWO stayed locked on that 38 light-year distant target, its sensors working at maximum capacity. To ensure this wasn't an instrumental ghost, a glitch in the American-made mirrors, or a software bug, NASA reached out to independent observatories. The European Extremely Large Telescope in Chile and the giant radio arrays in the Australian outback were tasked with cross-referencing the signal. The data was rechecked 200 times by different teams who were intentionally kept in the dark about each other's results to prevent bias. James and his engineering team ran simulations to see if anything else could explain the oxygen-methane combo. Could it be a weird type of ultraviolet photochemistry? Could it be a specific type of volcanic outgassing unique to a planet with 1.2 times Earth's gravity? One by one, the abiotic, non-living explanations were crossed off the list. The mathematical models kept pointing back to a single conclusion. The probability of biological activity was calculated, refined, and finally settled at 73%. When that number, 73%, was finally leaked to the press, the world ignited. The 73% became a global icon, plastered on the front of the New York Times and scrolling across news tickers from Tokyo to London. It was high enough to spark a revolution, but low enough to maintain a maddening sense of doubt. In the streets of New York, Crowds gathered to look at the constellation of Cygnus with the naked eye, knowing that somewhere in that darkness, something was living. Inside the Goddard Space Flight Center, the mood was different. The scientific community was locked in a civil war of data. 73% is not a discovery. It's a taunt, shouted one skeptic during a heated symposium in the auditorium. But as the weeks turned into months, and the independent observatories confirmed the same spectral lines, the skepticism began to give way to a profound, quiet awe. The signal was real. The chemistry was real. "We've done the math, Sarah," James said late one night, looking at a montage of news clips from around the world, showing people praying, celebrating, and even panicking. "The world is ready for an answer." "The world wants a yes or a no, James," Sarah replied, her eyes fixed on the raw data scrolling on her screen. "But the universe usually speaks in maybe. We have confirmed the world breathes. Now we have to find out if it thinks." The global frenzy over the 73% probability was still at its peak when the data from the HWO took a turn that silenced every room at NASA. It started as a footnote in a weekly calibration report. James was the first to notice the deviation in the light curve. While the telescope was designed to measure the chemical composition of the atmosphere, it was also constantly monitoring the planet's brightness. "Sarah, you need to see this," James said, beckoning her to his terminal in the late hours of a Tuesday night. "I was running a noise reduction filter on the 452X photometry. I thought it was orbital jitter or maybe a sensor artifact, but it's too rhythmic." He pointed to a flickering line on the screen. It wasn't the star's light. The coronagraph was still perfectly masking that. This was a periodic fluctuation in the light reflected from the planet itself. Every 11 hours, the planet's brightness increased by a fraction of a percent, stayed steady for 20 minutes, and then dipped back down. Initially, the team assumed it was atmospheric rotation, perhaps a massive reflective continent or a permanent cloud deck was coming into view as the planet spun. But as they gathered more data, the math didn't add up. Natural weather patterns are chaotic. They shift, grow, and dissipate. This signal was different. It repeated with the precision of a clock, yet the shape of the light curve was slightly asymmetric. A sharp rise, followed by a staggered, geometric decay. "It's too regular for weather," Dr. Robert Vance observed, leaning over James's shoulder. "A superstorm doesn't have a pulse. But it's also too irregular for a simple machine. If it were a satellite or a station, the signal would be a clean square wave. This has texture." The 11-hour pulse became the new obsession within the HWO team. They began to run Fourier transforms on the data, trying to break the signal down into its mathematical components. What they found sent chills through the engineering department. The pulses weren't just repeating, they seemed to be structured. Within the 11-hour cycle, there were micro-fluctuations, sub-signals, that followed a sequence of prime numbers. The mystery deepened when the HWO's infrared sensors detected a heat signature that didn't match the planet's dayside temperature. Something on the surface, or perhaps in the upper atmosphere, was venting thermal energy in sync with the light pulses. It was as if the planet wasn't just breathing chemically, but pulsing energetically. NASA kept this new data under a strict Level 5 embargo. They had already told the world the planet might be alive. They couldn't tell them it might be active without being certain. Internally, the atmosphere shifted from excitement to a haunting, quiet dread. For the first time, the word techno-signature was whispered in the hallways of Goddard. not as a theoretical possibility, but as a terrifying reality. "James," Sarah whispered as they watched the latest downlink, "if this isn't a storm, and it isn't a moon, then we're looking at something that has a purpose. We aren't just looking at biology anymore. We're looking at an intent." The mystery of Kepler-452X had evolved. It was no longer a question of whether life existed there, but what that life was doing, and whether that 11-hour rhythm was a heartbeat, a broadcast, or a warning. The 11-hour pulse did more than just leak. It shattered the scientific status quo, turning the HWO project into the center of a global geopolitical and philosophical tug-of-war. Within 48 hours, the Kepler pulse was the only topic of discussion in the hallowed halls of MIT, Stanford, and Caltech. The scientific community, once united by the 73% Biosignature discovery, was now fractured by a fierce, intellectual civil war. Dr. Sarah Miller found herself at the center of the storm, testifying before a closed-session congressional hearing in Washington, D.C. The mahogany-paneled room was filled with generals, senators, and the president's top advisors. The question was no longer about oxygen. It was about whether American tax dollars had just discovered an alien civilization, and what that meant for national security. "We must remain grounded," Sarah argued, her voice echoing in the silent marble chamber. "Nature is a master of mimicry. We have seen pulsars that act like cosmic clocks and quasars that flicker with the energy of a billion suns. Before we jump to the conclusion of technology, we must exhaust every natural explanation. To be wrong about this would be the greatest failure in the history of science." The naturalists, led by Dr. Aris Thorne, a brilliant but cynical astrophysicist from Princeton, proposed the planetary ring shadow theory. During a televised symposium that drew millions of viewers, Thorne presented a complex model. He argued that Kepler-452X might possess a multi-axis, unstable ring system, the shattered remains of a captured moon. As the planet rotated and wobbled on its axis, these jagged, irregular rings could cast shifting, overlapping shadows across the cloud tops. This strobe effect, he claimed, was what the HWO was picking up. "It's not a signal," Thorne famously stated. "It's just the shadow of a graveyard." On the other side of the Atlantic, European researchers proposed the photochemical supercell. This theory suggested that the high concentrations of methane and oxygen in the atmosphere were reacting in a massive, planet-wide thunderstorm, a great blue spot, larger than the Atlantic Ocean. This storm would flare with intense lightning and chemical energy every time the planet's rotation brought it into a specific alignment with its star's magnetic field. It was a weather event, they claimed, on a scale humanity had never witnessed, but weather nonetheless. But in the quiet, sterile labs of Goddard, James and Robert Vance were looking at something the theorists couldn't explain. They had used the HWO's specialized processors to strip away the background noise, zooming in on the texture of the 11-hour pulse. James spent 3 nights straight without sleep, running the data through every filter available. "Look at the rise time, Sarah," James said, beckoning her to his desk. He pointed to a graph where the light didn't just fade in, it snapped. A ring shadow is a smooth, gravitational curve. A storm has a messy, chaotic tail caused by lingering lightning. This signal rises in exactly 1.6 seconds, holds for a duration that matches a Fibonacci sequence 1, 1, 2, 3, 5 minutes, and then drops off with a staggered geometric decay. Nature doesn't count in Fibonacci sequences. The techno-signature camp was growing. fueled by James's data. They argued that the pulse was too precise to be a shadow and too structured to be a storm. They proposed that the HWO was seeing the byproduct of a massive planetary-scale energy grid. If a civilization were using a Dyson swarm, a series of orbital mirrors, to manage their climate or harvest solar energy, the HWO would see exactly this kind of periodic, deliberate light fluctuation. The debate became a mirror for human belief. Skeptics saw the shadows of rocks. Believers saw the lights of a city. NASA's official stance remained agonizingly cautious, paralyzed by the weight of the discovery. There is no confirmed alien technology on Kepler-452X, the press releases stated daily, but internally, the simulations were failing. No matter how many variables they threw at the naturalist models, rings, debris, volcanic flares, magnetic interference, nothing could perfectly replicate the 11-hour rhythm. The math was too clean. The pattern was too deliberate. "We are looking for an excuse to stay alone," Robert Vance remarked during a late-night session, his silhouette framed by the glowing monitors. "We are trying to fit the square peg of alien intelligence into the round hole of planetary physics because the alternative is too big for us to handle. If we admit its technology, then everything changes. Our religions, our laws, our place in the universe, it all becomes obsolete in a single 11-hour cycle." As the debate raged on Earth, Kepler-452X remained silent, yet screaming with data. Every 11 hours, like a distant lighthouse in the dark, it sent its message across the 38-light-year void. The world was no longer just watching a planet. It was waiting for a translation that might never come, caught between the comfort of the known and the terrifying reality of the discovered. The screens in mission control eventually dimmed, but the questions they raised stayed etched into the minds of everyone who had seen the data. The Habitable Worlds Observatory, a triumph of American ingenuity, had done what it was built to do. It had found a world that could sustain us, but in doing so, it had found something we weren't entirely prepared to meet. The 11-hour pulse never stopped. It didn't speed up, and it didn't slow down. As the years passed, Kepler-452X remained a tantalizing blue speck in the dark, a world that breathed with oxygen and pulsed with an unknown rhythm. NASA's final report on the mission was a masterpiece of scientific restraint. It confirmed the existence of a biosphere with over 90% certainty, but on the matter of the pulse, the techno-signature, it remained silent. The official conclusion stated, "The signal remains an unexplained anomaly of planetary physics." But for James, Sarah, and the thousands of engineers who had built the HWO, the silence of the report spoke louder than the words. They knew that the history of humanity had been forever altered. We were no longer the only story being told in the dark. Narration. Soft, powerful. For the first time in human history, we have found a world that breathes. We have looked into the depths of the Cygnus constellation and seen a reflection of our own existence. Whether that world hosts simple microbes clinging to wet rocks or a civilization far more complex than our own, remains a mystery for the next generation to solve. The Habitable Worlds Observatory has finished its primary mission. It has shown us that the universe is not a graveyard of cold stone, but a garden of possibilities. The 11-hour pulse continues to travel across the void, a heartbeat from a neighbor we have yet to meet. The camera slowly pans away from the blue glow of the monitors, moving through the halls of the Goddard Space Flight Center, out past the telescopes and the trees of Maryland, rising higher and higher until the Earth itself becomes a pale blue dot in the rearview mirror. The universe has not answered us yet. We have sent our signals, we have built our eyes, and we have waited in the silence of the night. A final shot shows the HWO, a lonely sentinel in the blackness, its golden mirrors catching the light of a distant sun. The universe has not answered, but for the first time, it has started whispering. Fade to